We're going to start this lesson actually reviewing some about things that model linear and exponential functions. The first one says which situation could be modeled with an exponential function. The amount of money in a savings account where 150 is deducted every month. This is a constant numerical change, so that's going to be linear. The amount of money in Susie's piggy bank, which she adds $10 to each week, also constant numerical change, so linear. The amount of money in a certificate of deposit that gets 4% interest each year. So this one is growing exponentially because we're growing by percents. The last one, the amount of money in Jacqueline's wallet, which increases and decreases by a different amount each week. That's neither linear or exponential because we kind of have this random pattern going on. The next one says the selling prices for a group of cars were recorded when the cars were new and for an additional 5 years. The results are summarized in the tables below. Which car's price dropped at a constant percent rate each year? So here we're looking for that exponential change, constant percent rate. I'm going to kind of look for things that are obviously wrong. The first thing that's obviously wrong here is that this car's value goes up, so not decreasing. Looking at the other ones, this car's value also goes up, so it's not decreasing. And then between the other two, number one is going down by $5,000 a year. So that's linear. Now, by process of elimination, I know 3 is the answer. To find a constant percent rate, we want to divide the second number by the first number and see if that pattern continues. So if I do 20,000 divided by 25,000, that's going to give me 0.8. And then if I take the next two and do the third divided by the second, we see the 0.8 again. So this one, from the 0.8, we can tell is decreasing by 20%. 1 minus 0.8 is 0.2, and 0.2 represents a 20% decrease. Really, we're looking for that multiplier. Each time when we go from value to value, we're multiplying by 0.8. So this one shows that percent decrease each time. The next one says Joseph's taxi charges $10 for the initial service of any drive. The fee for each mile of the taxi ride is 0.75. Which type of function is represented by this situation? So I have a start value, which we could have with an exponential function as well, and then it's going up by the same number each mile. So that's linear, constant numerical change.